Well, so the other day we talked about how we can figure out what the graphs of the inverse cosine and inverse sine and inverse tangent look like. And you can see here in red, this is the graph of the inverse cosine or arc cosine. And in blue, this is the graph of the arc or inverse sine. And down here is the graph of the arc or inverse tangent. And the important thing to realize about these graphs is in order for these to become functions, in order for them to pass the vertical line test, we had to really restrict the domains and the ranges that we were working with. So you'll notice that arc cosine or inverse cosine only covers values from 0 pi up to pi. And so in our unit circle, we're talking about values from here to here. So when you're talking about regular cosine, regular sine, regular tangent, the unit circle and all the cycling around the unit circle, either direction goes. We can handle an infinite number of angles. But when you're talking about the inverse trig functions, the arc trig functions, we're very limited. And cosine only exists, inverse cosine only exists from 0 to pi. Look at the graph for arc sine. It only goes from negative pi halves up to pi halves. So arc sine lives only in quadrant 1, which is 0 to pi halves, and kind of quadrant 4. But this is no longer 3 halves pi. It's going to be negative pi halves. So in order for arc sine to exist, we have to be very restrictive. And it goes from 0 up to pi, and then from 0 down to negative pi halves. It doesn't go from 0 to pi and from 3 halves pi to 0. No, because it has to be continuous. And the only way this graph can be continuous is to dip into the negatives. And if you look at it, inverse tangent or arc tangent will follow the sine curve. So that's where we have these ideas that we talked about the other day of things like the unit taco. And you'll notice the unit taco applies to the arc cosine. And we talked about the unit burrito. And obviously it was a very hungry day for the students who came up with this idea. But the unit burrito applies for sine, arc sine, and arc tangent. So let's dive in and see how we use these with some pretty basic exercises. So the first batch of exercises, we just need to figure out the exact value of these trig functions. So the first one I'm looking at is the arc cosine of negative a half. Now another way to think about what this is saying is just to reverse it, to go back to the original function. This is saying that we can take the cosine of some mystery angle, some unknown angle, and we should end up getting this ratio of negative 1/2. So you can always take an inverse function and rewrite it in its original function form. But I think that's kind of ridiculous. I mean, if we're talking, after all, about the arc cosine, we'd want to look at our unit taco, and we want to think about, okay, where in this unit taco is the cosine negative? And we know the cosine is negative in quadrant 2 over here. And where will the cosine give us a value of negative 1/2? Well, if it's cosine, we're looking at a steep angle. And of course, that steep angle right there in quadrant 2 is none other than the answer to this problem, which I can't find. It's somewhere in this. Oh, there it is. It's up here. 2 pi over 3. Let's try another one. The inverse sine or the arc sine of radical 3 over 2. Now we're talking arc sine, so we want to look at a model for arc sine, not the unit circle, but the unit burrito. Radical 3 over 2 is positive. I know sine is positive up here in quadrant 1. And radical 3 over 2, that's a pretty big value. So if I'm looking for a sine function that's pretty big, I want this steep angle right there. And in quadrant 1, that steep angle is none other than pi thirds. Let's try this one. The arc cosine of 2. Arc cosine, inverse cosine, I'm going to pick a good model, and that's the unit taco. Where in the unit taco is the cosine positive, and that'd be here in quadrant 1. And I need the cosine to give me a value of 2. Wait a minute, that doesn't make any sense. The biggest value that cosine could be is 1. We can never get a cosine value of 2. So you have to have the confidence in your unit circle, your unit taco, your unit burrito to say, this thing is undefined. There is no answer. And now let's look at a tangent problem. Well, let's look at an arctangent problem. The arctangent is -1. So arctangent lives in the unit burrito. I know tangent is negative down here in quadrant 4. Now remember, quadrant 4, down here we have negative tangents. The tangent is -1 at this bisecting angle. Now you know the bisecting angle in the unit circle, that angle right there would be called 7 pi over 4. But this is not the unit circle, it's the unit burrito. And this is not 7 pi over 4 down here, it's negative pi fourths. So be really careful when we switch to quadrant 4. Finally, the inverse sine of -1. Our model, inverse sine, unit burrito. So I go into my burrito. I want the sine value to be negative. You know the sine is negative down here in quadrant 4. Keep in mind, though, if we're in quadrant 4, this is 0 rotating to negative pi halves. You know the sine value is -1 straight up and down. So my answer, negative pi halves. Now let's step up the game and let's look at not some exercises, but some problems. And these problems are going to be a little bit trickier, I'd say, than our exercises. So let's take a look. What we have here is a composition of functions. I have a function of another function. And you may remember the way we handle this is we look inside at the innermost function first. So I'm going to play around with that innermost function first. So I'm going to keep cosine of something on the outside, and I have to figure out what this is on the inside. Now it's an arc cosine, an inverse cosine, and so I want to look at my unit taco. And where in that unit taco is cosine positive, radical 2 over 2? Well, you know it's positive when you're in quadrant 1. And you know the cosine is radical 2 over 2 right here at this bisecting angle, right there. So what is that angle right there, this bisecting angle in quadrant 1? Well, it's pi fourths. So this entire red box, this inner function, simply becomes pi over 4. And now, when I take my outer function, the cosine of pi fourths, well, it's a cosine function. So I can now go to my unit circle because it's cosine. And notice in my unit circle, this is now 3/2 pi, or I mean, it still could be negative pi halves. But I need the cosine of pi fourths. Well, pi fourths is this quadrant 1 bisector. And I know that the cosine of pi fourths is none other than radical 2 over 2. And oh, that makes sense. Because usually when a function comes across its inverse, it's as though they just kind of cancel each other out. And you're left with whatever you started with, radical 2 over 2. And that's usually what happens. Usually. Let's keep going. Number 2, the tangent of the arctangent of -5. Well, arctangent, I know that the arctangent, that is that's a unit burrito. So I'm going to start at the innermost set, and I know in the unit burrito, tangent, where is it? Tangent is negative down here in quadrant 4. But I don't know where the tangent is -5. I know where the tangent's -1. That's right here at the bisector. I know where the tangent is undefined. That's straight down. -5 is somewhere down here. And I don't know where it is. But I do know this. I know that whatever this is just some angle. And I'll call it alpha. And it's some angle that produces a tangent value that is -5. I don't know, it's probably a pretty steep angle. And I know when I take the tangent of that angle, I know what I'm going to get. I'm going to get I'm just going to get -5. Because usually a function and its inverse, they just undo each other. Usually. Let's keep going. So now we have the arcsine of the sine of 3 pi over 2. So let's just take a look at this, the arcsine of the sine of 3 pi over 2. So I'm going to start right here in the innermost set of parentheses, and that's the sine of 3 pi over 2. Now what is the sine of 3 pi over 2? Well, it's just sine. It's not arcsine, it's just sine. So I'm going to take a look at the unit circle, and I'm going to say, well, the sine of 3 pi over 2, that's right here. That's simply, I know what that is. That's -1. So this just becomes the arcsine of -1, just straight down. It's just the arcsine of -1. Now, what is the arcsine of -1? Well, the arcsine of -1, well, I can go to my unit circle right over here. Oh, my unit burrito, because it's an arcsine. And the arcsine of -1. Well, I know that sine is negative down here in quadrant 4. And I know the sine is -1 straight down here. So our answer to the arcsine of -1 is simply -pi/2. And now I'm going to pause for a second, because I think what happens is a lot of kids see this and their first assumption is the inverse sine and the sine will undo each other, leaving us with an answer of 3/2 pi. But that's not the answer, because the last thing we do is we take the inverse sine, and inverse sine doesn't allow for 3/2 pi. It allows for -pi/2, but not 3/2 pi. Remember, inverse sine goes from 0 to pi/2 and from 0 down to -pi/2. It does not complete the unit circle all the way around to 3/2 pi, because that would be discontinuous. And we want our function to be continuous. So let's get down to another example here, number 4. This might be worth your time pausing and trying on your own, and then we'll come back and check and see how you did. Well, okay, it's a composition of functions, so we always start in the innermost function with 5 pi over 3, and it's a cosine. It's not an arc cosine, it's a cosine. So anytime you're dealing with just a regular trig function, we go to our unit circle. 5 pi over 3 is where? It's in quadrant 4, and it's a steep angle. And I know that the quadrant 4 steep angle value right there for cosine is positive 1/2. So this simply becomes the arc cosine of a half. So now I'm in arc cosine. That's the unit taco. So I come over to my unit taco and I say, okay, where in the unit taco is the cosine of half? Well, I know the cosine is positive in quadrant 1, and it's a half cosine, the x value, at a steep angle. What's our steep angle right there in quadrant 1? Well, our steep angle in quadrant 1, pi/3. And again, you see that an inverse meeting a function doesn't necessarily cancel each other out. We got a different value than we did here. So you got to really think through these problems. Really think them through. One last example, or no, I guess 2 more. Oh, I guess 3 more examples. Let's do 3 more. Try this one. Go ahead and pause it. See what you get and come back. Okay, welcome back. Hopefully you started with the innermost set. That is a unit circle value. So we go into our unit circle. -5 pi over 6 puts us, right there at that shallow angle. So this becomes the arcsine of that shallow angle, which is missing. I think I need to write it. That shallow angle is 7 pi over 6. So what is the sine of that value? Well, that's -1/2. It's a shallow angle. So now we're talking